So, if we look back at accuracy and precision, what's the difference between the two of them? Ryan?
Accuracy is getting it right. Precision is being consistent.
Okay, very good. So you're looking for, if you're going to shoot something, like if you're a bow hunter or like a rifle shooter, if you have a good precision, that center grouping there, this one right here, if you have a tight grouping like this, what does that tell you? You need to adjust what? You need to adjust your sights. That's the whole point. So there's a flaw in what if your precision is off? Flaw in, starts with a T. Flaw in the tool. Alright, so in the book last week we read about accuracy and precision. Anybody tell me the difference between the two? Raise your hand if you know. Rain?
Accuracy is how well you did. The precision is how fast you did it.
Okay, close. Anybody else want to add to that?
Accuracy is like on target and precision is like constant.
Okay, accuracy is on target. What is precision? Alright, so if you're a hunter, like if you shoot a bow and arrow, this is your target, and you're doing this, what should you do? No. Okay. So what should you do if you're shooting a gun and you have a tight grouping like you see on precision? What should you do? Adjust what?
Readjust?
Readjust what?
Your aim?
No. Anybody ever shot a bow before?
Yeah.
What do you do if you have a tight grouping like this? Change the... No. Starts with S. What? Change the sights. The sights are the alignment of the bow. Change the sights. So it would be a bow problem and not a human problem, right? Does everybody understand that? The bow is out of... I was just telling the page.
The answer can be thought of in terms of density. The book-filled backpack contains more mass in the same volume. Density is a physical property of matter and is defined as the amount of mass per unit volume. Common units of density are grams per cubic centimeters for solids and grams per milliliter for liquids and gases. Consider the grape and the piece of foam in figure 2.5. Although both have the same mass, they clearly occupy different amounts of space. Because the grape occupies less volume for the same amount of mass, its density must be greater than that of the foam. The density of a substance usually cannot be measured directly, rather it is calculated by using mass and volume measurements. You can calculate the density using the following equation. Because density is a physical property of matter, it can sometimes be used to identify an unknown element. For example, imagine you are given the following data for a piece of an unknown metallic element. 5.0 centimeters cubed and 13.5 grams. Substituting these values into the equation for density yields 13.5 over 50 over 5 equals 27 grams per centimeters cubed. Now turn to table R7 on page 971 and scan through the given density values until you find that closely matches the calculated value of 2.7 grams centimeter cubed. What is the identity of the unknown element?
Okay, so if we look at the cubes I just passed out to you, what do you notice about them? Once you've seen them, you can pass them back. Raise your hand, what do you notice about them?
They're the exact same size, like,
What do you mean by size?
I guess,
Are all the same size, but they're way different.
I don't want size, I want the same
Volume?
volume. Yeah, they're the same volume. If you look at the diagram on the page there, see they're giving you a three-dimensional. Volume is length times width times height. So you can see things that have the same volume have a different mass. That's density. Now the first periodic table was set up based on this. They thought all the elements could be arranged based on the density. If you look at these blocks here, you can see that they have different masses, the same volume. So you take the same volume of the substance, element, and you just arrange it based on the density. We're going to pass around these cubes. These cubes right here. These are called density cubes. And I want you to notice something about them, so I'm going to pass them around. And then I've got several of them. Just kind of get you to pass them around. And then we'll read a little bit more and we'll come back to the density cubes. Okay, so who'd like to continue on reading? We're on as the air at the equator is warm. All right, go ahead, Adam.
As the air at the equator is warm, the particles in the air move farther apart and the air density decreases. At the poles, the air cools and the density increases as the particles move closer together. When a cooler, denser air mass hits beneath a rising warm air mass, winds are produced. Weather patterns are created by moving air masses of different density.
All right, so density plays a big part in weather. And if you've been following the news, what's in the Gulf right now? Yeah, Hurricane who?
Harvey?
Hurricane Harvey.
Centimeter for solids and grams per milliliter for liquids and gases. Consider the grape and a piece of foam and figure 2.5. Although both have the same mass, they clearly occupy different amounts of space. Because the grape occupies less volume for the same amount of mass, its density must be greater than that of the foam.
Okay, so they give you a visual there on the next page, 37, figure 2.5. And what do you notice about those two objects on the balance?
They're the same.
Same what? Yeah, the same mass. Now I'm going to pass around to you some objects that have something that's different. I want you to look at them and think, wonder how these are different. I wonder how they're the same. Now, water is very unique in that its density changes in two directions. The density of water is 1 at room temperature, which would be 25 degrees Celsius. And as the temperature gets colder, what does water do? Raise your hand. As the temperature of water gets colder, what happens?
It freezes.
It freezes. So what does that mean? Does it get smaller or does it expand?
It expands.
It expands, and that expansion causes the density to decrease. Everybody see that? Makes sense? Now, when you heat water, what does it do? Does it decrease in volume or expand? What? Think about steam. Does it decrease in volume or expand in volume? Water, when you heat it. When you heat water, when you have liquid water and you heat it, it's bubbling. You think that it's getting denser or less dense?
Less dense.
Yeah, it's getting less dense. Water, when you heat it, it expands. You didn't know that? And when you freeze it, it expands. Water's really weird. You cool it, it expands. You heat it, it expands. What's it doing? Where are you in the middle? Yeah, in the middle, water is the most dense. It's kind of weird, but that's what it is. Kind of cool. Water.
Weather patterns are created by moving air masses of different density.
Okay, so right now in the Gulf of Mexico, what's happening?
Hurricane.
Hurricane what?
Katrina.
Harvey.
Wait, there's another hurricane?
Yeah, Hurricane Harvey. Now, in the beginning of the year, we talked about how climate change and CO2 is doing what to the upper atmosphere?
Heating it up.
To the upper atmosphere, CO2 is cooling, right? Now, if the water is warm, will hurricanes form faster or slower?
Faster.
Faster. So the warmer the water, the faster the hurricane. Because the upper atmosphere is cooler. And you're going to get like a